I'm really, really indebted to you, the two of you. It is time to learn about the second way that light bends. Light bends three ways: through reflection, which we just spent the last 2 hours talking about with mirrors, then refraction, which we're going to learn about right now. This is mine, isn't it? Yeah, refraction, and then finally diffraction, which we've actually learned about in regards to sound. So here comes the second one, refraction. And I'm going to tell you what refraction is. Refraction is the bending of light when it passes from one medium into a different medium. The bending of light as it passes from one medium into a different medium. And you know, I don't have to do a lot of writing on the boards because this is all in your Talon notes. Pardon me, I am going to see if I've got the air conditioner on. No, I don't. Now I do. All right. Second. All right. Have you guys ever had that experience where you put a stick in water and the stick appears to have a bend in it as it enters the water?
Yeah.
Okay, well, next time you do it, go ahead and do it. I mean, I can do it right now. You know, I'm putting this stick in the water right now, and to me, it looks like the stick is going like that, bending like that. Okay, it's the illusion you get when you're looking at light from something out of water and something in water. Let me demonstrate this to you using light rays. Here. Really? This aquarium, I've put glow-in-the-dark powder in it so that you can see the light ray in it. Yeah, it's the cheap glow-in-the-dark powder. So I'm now going to turn off the lights, which I don't know what good that's going to do to people at home watching this, but here we go.
Whoa. Glow in the dark.
Do you see the glow in the dark? Now,
Ruining it. You ruined it.
yeah, please close the door. Okay. Now, can you see the light entering the water? Can you see that red laser entering the water?
Yeah.
Okay. Now, I have a white paper here in the hopes that you can see what the laser does as it enters the water. Is it entering the water? No.
Why is it not focusing?
You had it.
Well,
Yes, you had it. Yes.
can you see it? I'm in the way for many of you, but it's a perfect. Can you see it bending? It's
Yeah.
coming in at one angle, then it hits the water. and
Can't
the
see it
light
bending.
bends.
You can always
You guys
Google it.
seen that?
Yeah.
Okay, so
Google
do you
it.
believe in refraction of light?
I believe.
Okay, hope so, because that's as good as it gets.
Yep.
Okay. If I can draw on the board what happened, here's what happened. I had air here and water there, and I was shining a laser, and the laser was coming in at this angle. Then the laser hit the water, and tell me, how did the ray bend? Did it bend that way or that way? The second way or the first way?
First way.
Yeah, second way.
Second.
It bent like that. That's what the light did, if you remember. That's what actually happened. Okay? And so we measure the angle of incidence and the angle of refraction, not relative to the surface of the water, no siree. We measure it relative to the normal line of the water. This is the normal line. And so this angle here would be the angle of incidence. just like it was the angle of incidence with reflection. And this angle here would be the angle of refraction. And I'd like you to notice that when my light ray went from air to water, the light ray bent towards the normal. And I'm going to be using those terms. Did the light ray bend towards the normal or away from the normal? I'm going to be using those terms. So in this case, the light ray bent towards the normal. The light ray bent towards the normal. I need to now show you why refraction of light occurs. And the best way to explain it is to talk in terms of a single axle child's toy. Imagine I've got this situation. Imagine I've got a fast tile floor. This is a fast tile floor. And then here I've got deep shag carpet. And I've got a child's toy that has a single axle, the type of toy where it's a single axle with two wheels and there's a stick attached and they're walking with it, you know. And so this single axle toy is coming towards the boundary of the fast tile floor and the deep shag carpet. So that cute little child, cute little irrepressible child, is pushing their single axle toy until you get to here. Do you see that the right hand or the bottom wheel is going to now be traveling on the deep shag carpet, which his little toy will move rather slowly, whereas the top wheel is going to stay on this fast tile floor. So what's this little single axle toy going to do?
Rotate.
Yeah, it's going to turn that way, right? Now you've got a situation where this wheel is traveling slowly, this wheel is traveling quickly. It's going to have the effect of turning the toy until both wheels are on the deep shag carpet, and then the toy continues on. Right here, let me exaggerate the effect. Here. Okay. So that now he's on the deep shag carpet, and you'll notice the toy turned. If you think of this in terms of a wave that actually has depth, you know, was it on?
Yeah, it's on.
Okay, a wave that actually has depth, you can see that your wave is going to hit, one part of your wave is going to be at the slow part, and the other part of the wave is going to be at the fast part, and you get that bend. If I can draw this as a light ray, then you're looking at this. The ray goes to here, and then it hits here, and now it's going like that. You see? The same sort of bend that you experience with my aquarium. So there's a few facts about refraction that I want you to know, and we're going to answer those questions right here. So look at your chapter 26 in the Talon notes. You can keep, did you just turn it off or do you want to keep it?
No, I've been zooming in and out and stuff like.
Oh my God, you're so awesome.
Well, they can't
Yeah,
see
I
it
didn't know you were
from
like
here.
password stuff. Okay, look at your Talon notes. Look at chapter 26, number 1. Refraction is defined as the blank of a wave as it passes from one blank to a different blank. Someone, please fill in the blanks for the class. What should be there? Good. Bending of a wave as it passes from
Medium.
Yeah, please write that down. The bending of a wave as it passes from one medium to a different medium. Look at number 2. Refraction occurs because waves travel at different
Speeds.
right? When you go from a fast medium to a slow medium, you bend towards the normal, as you saw here with my child's one-axis total. Number 3, refraction is not a gradual process. The bending of a wave through refraction doesn't go like curved or something crazy like that. It's an instantaneous, abrupt change that only happens at one place. Look at number 3. Refraction occurs at the
Intersection.
here, or how about besides intersection? What's another name? What do we call this?
Boundary?
Yeah, boundary. Good for you, Chris. Yeah, the boundary. Refraction occurs at the boundary of two different media. Great. Now that you've got the conceptual reasons for the where and the why of refraction, it's time to start doing some math. And the first mathematical term you need to know about is the index of refraction. The index of refraction, which we call n because the word index starts with the letter N, kind of. And the index of refraction is a ratio. It's a ratio of the speed of light, and that would be like the normal speed of light, like the speed of light in a vacuum, divided by the speed of light in whatever medium I'm getting the index of refraction of. So please, for number 4, write that down. The index of refraction, speed of light in a medium, speed of light in a vacuum divided by the speed of light in a medium that you're in.
Can't really push on it. Yeah.
You've heard it said that nothing can travel faster than the speed of light. Are you guys aware of that? Okay, nothing can travel faster than the speed of light. Albert Einstein says that. But guess what? Light can travel slower than the speed of light, right? Light travels fastest in a vacuum, but when light travels in any other medium, it travels slower. That's because when light starts passing through a different medium, all of the molecules of the medium have to absorb and then re-emit that light. That light doesn't just pass through. The light gets absorbed, re-emitted by every molecule that the light hits. And so that slows the light down. For example, tell me, what is the speed of light in a vacuum? Good. 3 times 38 meters per second, right? C, we call it.
That's an 8, by the way, not a 2.
Well, I'm going to ask you to get me the index of refraction of water with this knowledge. The speed of light in water is 2.25. Let me see if I have a problem with how she's doing that. Just one second. No, I don't. Okay, the speed of light in water is 2.25 times 10 to the 8th meters per second. I'd like everyone to please find me the index of refraction of water. Give me the index of refraction of water right now.